Hi, thanks for checking out our channel. This is going to be a hopefully repair video on this particular unit. This is a Gallagher M1500, the old version. This one is from 2002 is when it was manufactured. 02 is the year it was built. They started making this version with this kind of look, purple case version, back in like 1990 with this name on there, 1500. They had a earlier version in the mid to late 80s called a Super 60 with a little 2, like second version, I guess. Had a picture of a sheep on the front of it, or lamb on the front of it, whatever it was. Those are very similar to this unit, just a different name. Same similar guts, but you know, this unit was they made that unit all the way until 2003 or 4, 2, 3, 4, somewhere in that range when they stopped making it. So this is basically about a 35, 40-year-old design. Even though this unit's only 22 years old, it's based off of an old style design from back in the 80s and early 90s. Well, anyways, we're going to take a look at this and see if we can get it going. I love working on these old units. These old Gallaghers are just old school electronics, tanks of a unit, just work. The note on it says unit will not power on. So, you know, with it being this old, nothing loose inside, that's nice. With the age of this thing, who knows what could be wrong with it. So we're going to have to take it apart and see what's going on with it. We'll also look and see if any of the parts have been changed in it. We'll see if there's any date code stickers on any of the boards. Uh-oh. I see some burnt arc and residue inside there. Is that from a previous repair? Is that something that's happened recently? Oh, no, it's been going on for a little while. You can see it down inside there, this residue there. It's been arcing, probably coming from that transformer. Oh, I can tell you right now the capacitors are factory from 2002 because this is what they look like as they age. They were white originally, and as they've ran for 20-some years, they've discolored from age. And the sticker, the double-sided tape is also, this used to be white and it's all faded. Circuit board looks like it's the original too. Didn't have the sticker on there, but you can definitely tell been around a while. So we got a hot spot there on the capacitor. Now that's just cosmetic because right here, a little black thing underneath that little metal clip here has a thermal fuse, thermal cutout, and so this resistor gets really hot, and so the heat from that will discolor the side of that capacitor. So that's just cosmetic. And then now looking at this board a little closer, this little MOV is bad. So that's a surge suppression device usually. So we need to do a little work to this board to have a chance of firing it up. Let me get the soldering iron worn back up. We'll set that board to the side there. Let's while it's warming up, so it'll take a couple minutes to do that. Let me get my multimeter out. We're going to do a little testing on the inside. Let's check the fuse. This version luckily has a fuse on it. Some of them didn't. Fuse is good. Now we're going to check the capacitors. These are 30 microfarad capacitors, so they're wired in parallel, and capacitors in parallel add up. Should be right around 60, so we're reading 41.4 out of 60, so those need to be changed out. I gotta see if I've got any, or ones that will work. I gotta look into that. Let's see here. Take this board, I think is original. That sticker on there has been on for a while, and it's all the date on it's all wore off, so it's probably original. Let's pull this board out. This is the output. They call it a VDR board. It's an output protection board. It does like 3 things. It takes the power from the transformer, puts it there on these 2 terminals there, from these 2 terminals here, and it spits it out to your fence and ground, so it connects your fence and ground together. And then it has this big white resistor there is used as a voltage divider. This has a half power terminal on there. That's what that resistor right there does. And all these little orange things here, the yellow, whatever you want to call them, are bigger surge suppression devices than what's on that board. This is like a lightning protection board. And then also has a little light bulb here that gets protected and fed by this capacitor and diode resistor assembly there. And that tells, as long as the light's flashing, that means you've got enough voltage coming out of it to maintain your fence, maintain a good shock on the line. I think it takes about 3,000–4,000 volts minimum to make that light flash. So if the light's not flashing, either the bulb can burn out. This bulb's still good, but sometimes you'll see them black and it's really burned out over time. If the light is not burned out and it's not flashing, either the transformer's got a problem or you got a bad short in the fence dragging it down. Then the only way to know for that, you got to unhook the fence to ground, plug it back in, see the light goes flashing or not. If it still doesn't, then you know you got more problems on the inside. That's the basics of it. But let's we'll leave the capacitors alone for now. We'll eventually change them, but let's check the primary first of the transformer. We're gonna ohm it out here to here, so it'll be about 0 point something ohms. 0.2, that's fine. Just the primary input side of the transformer on any brand of fence charger is the same. The way you read them anyways is it's a closed loop to allow the main boards and the capacitors, however it's built, to discharge into it. So if it's open a reading or reads very, very, very high ohms, then the primary is open, and then the board and the capacitors can't discharge into it. So right now the primary is fine. The secondary side, that's going to vary from model to model, brand to brand. They're not universal on those, but should get some kind of reading on it. We're getting 11 ohms, like that's probably good for this one. I mean, sometimes I read 4 ohms, 2 ohms, 25, 30 ohms. They're all over the place. It just depends on what the internal resistance and everything is of the transformer and how it's built. All right, well, the solder iron's all warmed up. Let's get this board fixed. Let's see, I need some desolder braid. Soldering iron, of course. Solder. There's solder on some new parts. Alright, looks like that thing stinks. I can smell it. Got the electrical, putrid electrical burn smell going on with that thing. I didn't smell it when I first opened it up, but as it's kind of aired itself out and fumigating a little bit, it's starting to stink it up a little bit. Alright, so that's got to be changed. Now we're going to change out this thermal deal as well, because this thermal thing will burn or not burn, but go bad first. And if it doesn't catch quick enough, that little round piece goes next. And if that doesn't stop it, there's a lot more wrong than just those two things. Okay, so let's get our Nino's pliers out. I'm going to pull these two parts off the board. They've been different colors. They've been black. This one was originally blue. They've had orange, red, blue, black. They've been all over the place. It's just a freaking color. What they dipped it in doesn't mean it's different than the next, as long as the specs are the same. I think the ones that I have in stock are red. Alright, there's those two little pieces. I'm going to throw those in the trash. Don't need those. Alright, let's we got a whole big pile of them here. I got more in that little tray, but there's a blue one. Let's use that one. Red and blue are exactly the same, I think, just maybe different manufacturer. I don't know. And here's another one of them little thermal things. So we're going to put that across like that. And Gallagher always recommended to space, to bend those legs out and down. That was what the earlier versions didn't have that, but as time went on, that's what they recommended to do. So that's what we always do. Sometimes that can be a real pain in the neck to get on there, but it's on there snug, but it went on there. There's no polarity to it, so it doesn't matter which way it goes in. Same with this device here, there's no polarity to it. across and go down the side there. We'll bend those legs out a little bit so that way it doesn't fall through the, doesn't fall back through the board. Come on. Okay. Let's check this SCR real quick. Has a little heat sink on there. They're not super common to go bad, but they can. Reverse it. Ooh. That might be bad too. Okay, well, good thing I checked it because I probably would have plugged it in and it'd probably still be dead in the water. I gotta find some. Let's see, is this the right one? The one I'm going to use? That's the one I'm going to use. So when a power surge hits stuff, and it can do minor damage or it can do major damage. This isn't, you know, this is pretty minor. This isn't like super bad. So we're going to, and where I get all my parts from, all these SCRs, the MOVs, I don't buy anything on Amazon or eBay. I stopped doing that because a lot of, you know, you can get it cheaper from China and stuff, but half the crap I've got from there didn't last or would only run for like an hour or a half an hour or a few pulses or whatever and quit. So I stopped years ago, stopped buying component parts like this on eBay. I just got tired of having to do the work twice. So now we buy all our parts from different online, reputable online electronic places like Mauser, DigiKey, Newark. There's other ones out there, but that's the three I can think of off the top of my head. So now we're gonna, because they do all the vetting, you know, they get parts from actual manufacturers that build this stuff for a living, not a copycat Chinese made one. Alright, put the heat sink back on there. I think this one, well, it's the same exact one. I thought maybe this was the one I put on might be a little bit bigger when it comes to amps and voltage and stuff, but no, it's the same exact one. Now, if I plug this in, it still won't run, or it runs like clicks once and stops, then we've got a bad transformer that's causing it to backfeed and pop that SCR. Because you remember, that case has all that sooty stuff inside, and I saw some of it down inside the transformer area down here. So we might have something arcing. You can see it up here too. So something's probably arcing. Right now, I think electrically it tests fine. But let's plug this in here real quick and see. See if it goes working or not. Here it goes. 1, 2, 3. All right. So far, so good. We'll put this output board. We'll put it back in there in a second. But let's check the peak voltage out of the transformer itself. I think these black transformers that they used on these M1500s, I think they put out about 11,000 volts right here at the terminals. Yep. So far so good. And then this, of course, is going across fence and ground, all these little electronic parts. It does put a little bit of a load on the unit, not much, but it will drop down, I don't know, 8,000 volts, something like that, because it is doing a job, and it's going across the terminals there. Light's flashing, see it? So far so good. I got to do another test besides just check the voltage on it, and we'll do that here in a second, but I'll explain what I'm doing versus showing you, because it's kind of hard to show. A little lower. Alright, we got to change the capacitors, which I can just swap them out. It's not a big deal, and I don't think I need to show you how to change out capacitors, and just undo wires and wire new ones on. Make sure you put them in the right spot. Let's get this load. Actually, we'll do the load test here in a second. Let me do the ground. I call this a ground fault test. I don't know internally what Gallagher calls it, but I've always called it the ground fault test. So we're going to plug this into an outlet that's got a... Oh shoot, hold on. I got to do something else for it. Let me unplug it again. Then I need to plug in the vise I've got here. There it is. Plug that in there, which is tied to ground of the electric grid or whatever, electric situation, grounding. Ground system. So I'm going to take this wire tied to ground to the outlet. I'm going to touch it to the ground terminal. If everything is kosher with the transformer, it will keep on flashing, clicking, do everything it's supposed to do. Now, if there's a problem with the transformer, when I do this, it will still click. It'll get a little louder, and that light will stop flashing. You can do this in the field as well. All you got to do is have the ground system hooked up only, and then plug with no fence, just a ground system, and plug it in and do the same thing. If it keeps on flashing and clicking, the transformer's fine. If it keeps clicking but the light goes out, you've got an internal short in the transformer. So here we go. Go here just to see. No, transformer's fine. Okay, oops. Now let's plug it back in real quick. We'll do a load test on there. So we're gonna go ahead and see what peak voltage is on it. Yeah, 8.3, 8.4, 8.5. All right, we're supposed to be. We'll put a 500 ohm load on there. Now, what the joule is supposed to be. This is a 15 stored joule, so probably 10, 8 to 10 output joules at the max load that we have on here, somewhere in that range. Now with the capacitor being a little lower, it may not get that high. We're already at about 7 joules, 7,000 volts with a 500 ohm load. Let's go to 200 ohm load, 7.5 joules roughly at about 5,000 volts. So if we put new capacitor, then we probably get it up over 8. We might plateau, we might go past its threshold. Yeah. Drop down to 6 joules, so we've cascaded or plateaued or gone past its threshold, whatever you want to call it. So it does handle the load just fine. So I imagine if we put new capacitors in there, we could probably get that 7.5, give or take, output joules up to 8 to 9, which is probably right where this one is. This is a 15 stored joule. 50% of that is 7.5. So usually on average, the efficiency of the transformers and everything else is usually between 50 and 70% of what stored is versus output. It's not a guarantee what you're going to get based on the stored joules versus output, But if everything's working kosher, usually between 50 and 70% is on average is what you get between what the stored joules is and the output joules is. Just like horsepower on a car or a tractor or whatever, you've got engine horsepower and you've got wheel or PTO horsepower. So if your tractor's say 100 horsepower engine on the tractor, you might have 65, 75 horsepower at the PTO. Or so you got a 500 horsepower engine on a truck or car or whatever, you might have at the engine, you might have 450 or 350 or 400, whatever at the wheels, but because you've got all that loss between the engine and the transmission and the drive line and the tires and everything, so you got a little loss between max and peak horsepower and horsepower at the wheels. So that's a little education for you. So we will change the capacitors out, and I'm sure we'll get a little bit more joules out of it. Won't change the voltage much at all, because that doesn't have anything. The capacitors don't have anything to do with the voltage on the output side of things. It has everything to do with the amount of joules that a unit will have based on whatever load is hooked up to it and stuff. So, well, thanks for checking out our video here. This is going to be the end of it for now. I'm going to stop the video and change the capacitors out. I've got plenty of videos on YouTube of doing that sort of job, so I'm not going to repeat that. So if you got a fence charger, old one like this, we would be happy to take a look at it for you. We work on all brands and ages. If it can be taken apart and worked on, we will work on it. And until next time, see you guys later on. Have a good rest of your day.